Welcome, everybody. So, we had some exciting news that came from NASA just today, and I'm going to try to talk through it some, and we'll see how this goes. So, um, stay tuned, and we will talk about what they had. So, there were actually two announcements that were made as far as NASA is concerned. And we're going to look here at some of the pictures of what they have. So, the first one is there's an instrument on the Curiosity rover that's called SAM that is a spectrometer. And they used it and they found that there was sulfur in some of the carbon organic materials that they had found. Organics have been long hypothesized on Mars. Curiosity was actually the very first spacecraft to actually detect them, though. So that was pretty exciting that it was able to do that. And as a result, we have learned a thing or two about what's going on the surface of Mars. The things that we're able to detect are much more complex organics than we've seen in the past. We knew about some so organics, for those who are not super steeped in chemistry, is any kind of chemical compound that deals with carbon and hydrogen and oxygen. It can have other things in there too. Somebody who's a real chemist is probably cringing at my definition there, but it's close enough. It doesn't necessarily mean that it has to do with organic life, but they are necessary ingredients to organic life. And carbon, we know, is the foundation of most of all of the life on Earth, really. Although obviously there are other chemicals and atoms involved too. So organic chemistry, simply put, is the chemistry of carbon. And so Curiosity was able to detect a lot of these very complex organics, which we've seen them in comets and asteroids and things like that. It's not uncommon to see them in space, but it does bode well for the search for life, and it means that we're finally able to actually start getting somewhere with them. So I wish I knew more about this, but I don't. The chemistry is beyond my able to get from the first reading, and I'll see what I can do to continue. The thing that I do understand a lot better is this chart. This is the seasonal methane. So we've known for a while that there is methane on Mars. And it's been kind of perplexing because sometimes it's there and sometimes it's not, and nobody's really been able to get a good grasp of exactly what's going on there. So they were able to finally plot it from the surface point of Curiosity over the course of a number of years, and they found some very interesting results. And so if you can look here, the blue values are year 1, the yellow ones are year 2, and then we're starting into the third year of Curiosity. And you can see that there's a seasonal trend that seems to match pretty well based off of what time of the year it is. Probably based off of temperature, so as most things like that are on Earth. This is really quite interesting. So the amplitude between the top and the bottom here is about a factor of 3. We know there are some spikes that happen that are quite a bit higher than this. So they've been able to model exactly what's going on, and they think that this is coming from some kind of underground reservoir. So what does that mean? Well, let me go back to some of the other charts that are here. I can't find the money chart. There are a couple of different possible sources as to where it could come from, the methane. And we know that methane would have a surface life of about 300 years on Mars. So we know there has to be something that's either creating it or replenishing it. And this is exciting because the vast majority of methane that's created on Earth is through organic life, such as bacteria or cows. We're pretty sure there's not cows, not really, really complex life on Mars, but bacteria is one possibility. So basically, there's two major things. There could be something biological that is seasonal, that only part of the time it's releasing it, which is a possibility, but it's not super likely. The other thing that's possible is some kind of underground chemicals that are holding this methane. So they're able to do a lot more tracking on this. And both of these are evidence for life, but they're certainly not proof of life. Now, I don't know exactly what will end up being caused, what will be discovered through here. But they're very interesting evidence, and they're even better evidence that we're sending the right spacecraft to Mars in 2020. So 2020 is the next time that we can send spacecraft to Mars. Right now, we're sending the InSight Mars lander. And in 2020, there's two rovers that are going of interest. There's the Mars 2020 rover from NASA, and there's the exobiology rover from ESA. And the ESA one is particularly interesting because it can drill much deeper in. Curiosity only has the ability to go basically skin deep. With the Exo Mars lander, they can drill quite a bit deeper, and they can help to figure out if these chemicals are present on the inside of Mars that will allow it to work. So let's just take a look at some of these videos. This is a spectrograph that you can see, not a whole lot of interest, but they can tell exactly what kind of molecule in this thiophene is the type of organic compound that they found. Some more organic chemistry, but this is a very large, complex organic chemical, obviously. And this is one thing that they believe they have found, which this is really quite exciting that something this large could be found on Mars. This is much, much larger than anything that we've detected. We've barely been able to detect organics at all on Mars, and now we've detected a very complex chemical. It bodes well in the search for life, but it's certainly not the end-all be-all. I think this video shows how some of the measurements are taken. So this is a spectrometer, I believe. It's on the surface of, or on the Curiosity rover, that they can put samples in and detect exactly what they are. Intake valves. Oh, so SAM is the spectrometer. This little valve has the ability to ingest air. And so I took a tour of Goddard a couple of years ago, and they were lamenting that all anybody wanted to do was detect methane and the light chemicals on Mars. They can only detect either the light ones or the heavy ones at any particular moment. I think there's 4 different settings, and they were always using the lightest one because of this discovery of methane. They were hoping to use some of the heavier ones to detect stuff like this. It's an example of what it looks like. You could take a panoramic view of what Gale Crater looks like. Very amazing instrumentation that we've been able to send to Mars. This is all the resources that they provided for the media. We'll just kind of skip through a little bit. Very beautiful, but very much a dead planet. You can see what it's like when it drills a rock. This is way longer of a video. You see it has a robotic arm. It goes down, it drills, brings the samples back up. It can only drill into a rock just a little ways, just to kind of scratch the surface. It also has the ability to do lasers. So if you take a look, this is an interesting image. The Gale Crater is a bedrock. This could be a scene from Earth. You would hardly know that this is actually something that is Mars unless you A, notice there's no plant life, and B, you're specifically told. This looks like a dried lake bed. I don't know. I lived in the desert in Arizona, and you'd see stuff like this all the time. Usually with a little bit more life, but an area where it's been wet and then dried up, it'll look kind of like this with mud chunks and whatnot, and then eventually it'll dry into something like this. So it's a very, very interesting area that they chose to go to. See if there are anything else interesting. See Curiosity. It was assembled and put together in a clean room so that they hopefully could keep the organics away. Very important stuff. Talk about ExoMars. Yeah. Here's the 2 rovers that are going to be going to Mars in 2020. That'll be really exciting. I'm going to see if I can find the other chart that's really interesting. Let me know if you guys have any questions, and I'll see if I can work through them. I'm not a planetary scientist. I do understand the robots and technology fairly well, but I'm an engineer, not a scientist, so... This is the chart that I was looking for earlier, by the way. So this is all of the potential sources. Hey, Bradley. This is all the potential sources of methane and where it might go to. So UV radiation will break up the methane eventually. Once you have it broken up, it'll take off the hydrogen atoms. Hydrogen atoms will scatter into the cosmos, and so they'll kind of disappear. Turn into other things as well, and eventually this will all end up in relatively tame molecules. So we kind of understand where it's going, but where could it be coming from? So there are 3 sources that are hypothesized. So the most likely one, and they talked a little bit about this, they're still not really super sure where it came from, but the I'm going to totally mispronounce this. I'm not a geologist either. Methane clathrite. It can store methane. The problem is with this is it tends to be fairly deep under the surface, they believe, and the temperatures just don't vary that deep. So because this has such a strong seasonal variation, it implies that heat is somehow releasing it. So what they think is that there's a steady rate that it's being released, and that it kind of hides in the layers right below the surface, and then when that surface layer heats up, it releases them in fairly large chunks. So there are 2 other possibilities that if you go a little bit deeper, you have olivine, and when it's put in water, can release methane, and you also have life, microbes, which is the one that everyone's really interested in. How can we know which of these it is? More studies, simply put. With the exobiology rover that ESA is sending up in particular, it can drill deep enough to see what are the chemicals underneath the surface. And that should provide some really interesting results. Now, InSight, you might recall, does have the ability to drill into Mars even deeper than the ESA rover, but the problem is it doesn't have the instrumentation to detect this kind of stuff. It's only measuring the temperature. It's not measuring and the conductivity, the physical properties of the rocks, but not what kind of chemicals they're made out of. Okay, So enough of me talking. What questions you guys have? You guys got to have something. And I might even be able to give an answer. For now, we'll just watch Mars rotate around. Because why not? So, a few other things. Methane was detected on Mars first about 15 years ago, I believe. And they've been slowly narrowing it in. The MAVEN orbiter that was sent to Mars, I think 26 months ago, roughly, whatever, about that long, its primary purpose was to detect the methane. So, yeah. Sorry, I don't deal with personal questions. Good luck, though. Good luck. Okay, so the MAVEN rover, it's an orbiter, excuse me, that's been trying to detect it, and they found that it's very regional, which is kind of interesting. So it implies that there's some little pockets that are releasing all of this methane, and it's either pockets of life or it's pockets of like volcanic activity. Let me see if I can find a map of where the methane's coming from. Not the best image, but you can see how much of a methane concentration there is in various levels. One thing I found really interesting, the questions that came out in the press conference were actually pretty technical for the most part. Usually with stuff like this, they tend to be a lot more human type questions. You know, towards the end they were like, hey, we've had too many technical questions. Let's get some of the kids. So you can see here the pockets that are higher methane concentration. It might be interesting to send in a mission to explore these areas of high methane that's meant to detect it, figure out what it is exactly that's causing it. There's got to be a better map. Yep, I'm not finding it. Okay. One thing I will tell you, Bradley, I am working on a presentation to figure out exactly how much it's going to cost for a ticket to Mars on one of the first missions. And of course, it's a lot of money, and it's going to be a lot more than the $200,000 that Elon Musk is talking about. It will be eventually, but it's quite interesting. It's quite interesting. Your comment reminded me of a comic. I'm sure you know exactly what I'm talking about, but I have to show this to you. So yeah, they don't bring rovers home. It's far, far too difficult. Okay, well, if nobody else has any questions, thanks everyone for joining me. I will go ahead and take it now. Feel free to leave questions in the comments, and I will answer them as they come. If there's enough of them, I might make another video. But the real short version this is an exciting discovery. It's more interesting than I thought it was going to be. Um, they've found the seasonal variations of that are in very, very high levels of this methane gas. They don't think it's high enough to be able to tell if it's organic or not. There are some ways you can tell if it's organic, but you have to have a lot of it. There's not really that amounts yet. But this is the best step forward we've had in the search for life on Mars. When we very first sent the Viking mission to Mars, we tried to detect life. And the way that worked is it put a little bit of water into a scoop of Martian dirt, and it looked to see how it reacted. And it figured that if it reacted with water, it was probably life. Well, it did react with water, but it reacted too fast to really be life like anything we know it. So they had some really mixed results, but we've been slowly homing in first on water and now on organic chemicals. And we're starting to just really build the foundation for what is there. And pretty soon, we'll be able to start sending missions to start looking for life again that are really targeted. Now, I don't know if that'll happen before we send humans there. If SpaceX has their way, we have 3 more cycles of missions to Mars until we're sending humans there. But who knows? But thanks so much for joining me. Let me know whatever questions you have. And until next time, keep on tracking and take care.